Hey physics kids, this is Mr. Galoya coming at you. Hey, we're going to be doing our activity number 6. That's the tinkercad lab number 6 sequential LEDs. And so this will be the last one that I'll kind of do with you, and we'll be really then now ready to kind of do the final project. And that's where you'll kind of pick a circuit and you'll kind of tinkercad it. So let me go into my student sign in here, and let me put in my class or class code 33LF TAQ L1CN1. And let me put in my nickname, Alan Cloya, student 4808. And that's me. And let me go into circuits. I'm going to create a new circuit. And let me give it kind of a name here. I'll just call it Lab 6 Homeschool Sequential LEDs. Now I've got the handout for you that I created on my Google Drive, and we're going to be using kind of we're going to be using a 555, but we're also going to be using this kind of new integrated chip called the 4017, and it's got more pins, but it's numbered kind of the same way. We'll start at the bottom left, and we'll number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And if you go to the next page, there's a picture of me. I already have the circuit built, and there's kind of what it will look like. And then the schematic is on that next page. Now, a special note, this schematic, it's a little bit of a different schematic than, so on page 2, I built the circuit with the breadboard, and I included a YouTube video of the real circuit working, and the circuit I actually built is a slightly different schematic, but it's basically kind of the same idea here. I thought this schematic was a little bit easier. Now this schematic mentions that we can go from 6 to 12 volts, and that's not really true with this simulation, because we're actually going to be using a different type of a 4017 chip that's a little lower power, and so we're just going to use a total of 6 volts, and everything I think should be fine. Okay, I'm going to move my schematic over to my other screen. So why don't we start with a breadboard, and I'm just going to basically put in this breadboard here, and let me kind of move it a little bit over here, and I'm actually going to be using 2 breadboards, and so I'm going to be getting another one, and I'll show you why we'll be using 2. And I'm going to rotate this one around, and I'm going to be using this breadboard for the LEDs. Okay, so let me get some batteries here put in. And let me bring in a battery, and let me do 4 total. That'll give us 6 volts. And I'm going to wire the batteries up to this side. So there's my negative. So I'm going to put it to my negative rail there. And here's my positive. And let me attach a wire so my negative rails are hooked up. Negative to negative, and I'll wire up the positive to the positive. Okay, now I expect, this will be a kind of a complicated circuit here. I expect it's going to take me a while to get this video done. I'll probably be pausing it, working with different parts, and then combine it at the end to make one complete video. So if I pause the video, I'll come back. So let's I'll come back and keep talking. No worries, everything's good. So let's get our 555 timing chip. So I'm going to put it over here. And let's grab our 4017. So I'm going to type in 4017. Oh wait, I can't do that just yet. This is my 555. I want to type my 4017 in this box. Sorry about that. And we're going to pick then this, it's called the 74HC 4017, and I'm going to slide it over. So it's kind of over here. Okay, so we got our batteries. Everything is hooked in with our batteries. We've got our two chips. And I think what I'll do is I'm going to put on my LEDs here. I'm going to show you kind of what I'm going to do here with that before I start. So I've got my LED here. And what I'm going to do is spin it around here. Again, we've got our anode and cathode, and I'm going to kind of put it right here. And I'm going to basically Control C and Control V, and I'm just going to kind of skip a line. And if I've counted this all right, I should be able to get 10 of them kind of sequentially on here. I want to leave a little bit of space where I can put some wires. Okay, let me count them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10. Now they'll be labeled on your schematic. They'll be labeled 0, 1, 2, 3, 4, all the way up to 9. So these numbers here represent the LED. The numbers below it represent the pins that we'll use on the 4017 to make our connections. Okay, why don't we start doing a little bit of wiring. I'm going to start with the 555. So we need a wire from pin 1 to the negative rail. Okay, pin 1. So again, 1, 2, 3, 4, 5, 6, 7, 8. So pin 1 to negative rail. Then I need pins 2 and 6 connected. So I'm going to put a wire from 2 to 6. Okay, 2, 3, 4, 5, 6. And then we can take a wire from 2, and let me just take another separate wire from 2, and I'm just going to kind of put it right there. And we need to then add what's called capacitor 2. So let me get a capacitor. And we want, it says 2 micro 2, that means 2.2 microfarads. So let me spin it here. Okay, again, this would be called capacitor 2, and it's 2.2. 16 volts is fine. So let me get a little label here. Okay, I'm going to call this then C2, 2.2 microfarads. Okay, now we want the negative. There's your negative terminal. We want a wire to the negative rail, and we want then the positive to go up here. So it's electrically connected there. Now while we're at it, let's put in C1. That's 100 microfarads, and that's just going to basically be from positive to negative. So let me kind of maybe move this over here. Oh wait, I think I did that wire wrong. Let me get rid of that wire. So that goes to the negative rail, and this goes over here. I guess, there we go. That goes to this connection that makes that connection with number 2. And let me kind of move this here. Okay, so let me grab another capacitor here. I'm going to call this C1. This will be 100 microfarads. And let me spin it. Let me put in a little note for that. C1. 100 microfarads. I'm just gonna use 100 micro F there, if that's okay. Now what we need, if you look at the schematic, what we need, there's your 100 microfarads, so we need the negative terminal to the negative rail and the positive terminal to the positive rail. Alright? Okay, so we need the negative terminal to the negative rail and the positive terminal to the positive rail. Okay. Now it looks like on my schematic here, we've got this stuff done. We've got this, this, and this. And we've got 2 and 6 connected. So I'm going to move my schematic back. Now I'm about at 15 minutes, so I'm going to stop my recording. I'm going to go ahead and stop my recording and save this video, and then come back to you here shortly. Okay, students, I'm back with you. I just kind of saved that first part. So what were we doing? We were doing C1 and C2. We got that taken care of. So if I look on my schematic, let me bring it back over here. If I look on my schematic, let's look at R2, R1, and this variable resistor. That's also called a potentiometer. Let's kind of work on that now. So let me move that off the screen. So we need a 10, so let's see, we need a resistor. We're going to call that, there we go. We need a resistor here. So let's bring that up. And we're going to call this resistor R2. And it's going to be a 10K. So this will be 10 kiloohms. There's your kiloohms. Okay, so R2 10K. So let me get a little, we'll call this R2 10 kiloohm. Okay, now we want one of the terminals to come off of that wire from pin 2. So we're going to put this down to this wire here. Okay, that looks pretty good. So again, this is the wire coming off of 2. And we've got it at 10K. And we want it to really connect to pin 7. So I'm going to take a wire and go from 7 to that column right there. All right. So let me move this down here. Let me kind of move that over there. Okay, so connecting on into this column, then we also need another 10K resistor, and that's going to be R1. So I'm going to copy this and paste it since it's the same. And I think what I'll do, I'm just going to put it, rotate it around. I'm just going to keep it kind of above this breadboard. We'll call that R1. Again, that's a 10K, so let me annotate it. If I can do that, here it comes. So this will be R1, 10K. And so what I'm going to do then is I'm going to have a wire here. I'll just kind of go right there, make a connection. And then the other terminal to this wire goes into a variable resistor, RV1, which again we would call a potentiometer here. So I'm just gonna put it maybe right there. And so this would be RV1, and that's going to be a 220K. So I'm gonna, so 220 kiloohms, and let me, okay, it's called RV1. Again, that's called a potentiometer. If I can spell it. And that's 220 kiloohms. Okay, so we want a wire from this other lead here to the first terminal here. That would be terminal 1. And the other lead, which would be right here, terminal 2, will go into the positive rail here. That makes sense, kids? So let's go back now and look at our schematic. Okay, we've got C2 and C1. We just did R2, R1, and the potentiometer. So we now need a wire from 4 and 8 to the positive rail. Okay, well here was pin 8. So I went it to the positive rail. Check that there, and then we want one from pin 4. There's your pin 4 to the positive rail. So it looks like the timing chip is almost all complete. Now here's how we're going to start wiring up the 4117 now. So we need a wire coming from pin 3 of the 555 to pin 14 of the 4017. Now again, the 4017, we'd start numbering here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so we want a wire from pin 3 to 14. Pin 3. Okay, there was pin 16, so we want it on 14. Okay. And since we're kind of right there, we need a wire from 16 here to the hot rail. Okay. And we need 3 wires. We need 3 wires coming to the negative rail. 8, 13, and 15. 8, 13, and 15. Okay, there was 8. Okay, 9, 10, 11, 12, 13. Okay, 13 to the negative rail. And 15 to the negative rail. Okay, so I think we're really now ready to do the LEDs. So let me kind of explain what we're going to do here. So again, right underneath the chip here, we've got LED 0 up to 9, and these would represent then the anodes. The bottom would represent the cathodes. Now notice all the cathodes are put together, and then we're going to have a current limiting resistor, R3, that's going to connect everything there. That's why I'm choosing, that's basically why I'm putting these on their separate breadboard. And I'm going to use this not really as a negative rail. Oops. I'm going to use this here to connect all my cathodes with wires. So I'm just going to put a wire here. I'm going to put a wire here. Make sure you're doing the cathodes. Oops. I'll need to redo that one, don't I? And I need to redo that one. Yeah, I was putting the anodes on. I want the cathodes. Oops. So there's the cathode. Let me move that back so I have some symmetry there. Cathode. Cathode. Takes a little bit of time, doesn't it? Cathode. 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 And cathode. Okay, let me just verify it. Cathode. 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 Okay, looks like we're fine there. Now, so what we're going to do is we're going to now get a R3 470 ohm resistor. So let me put it down here and spin it. And I'm going to call this then again R3. And it's going to be 470 ohms. So make sure I change that all. Okay, 470. Now let me get a little annotation. Okay, so this will be R3 470. Oops, 470 ohms. Okay, so what we're going to do is we're going to make a common connection here. So I'm going to take a wire and go from here to one of the terminals of the resistor, and the other one will go to the negative rail. Okay. I'm going to stop this video and save it as part 2, and then I'll come back. Okay, I'm back with you here. So let me get that schematic. So we're now ready to wire up the LEDs, the anodes of the LEDs, to the pins to the 4017. So again, the top numbers here represent the LED. These represent the pins here. So we're gonna call this again. We're gonna call this our 0 LED, and we're gonna number up to 9. So our LED 0 will be wired to pin 3. So pin 1, 2, 3. So that says output 1. So that's going to be, we're going to wire that to the anode. Okay, the anode of the first LED, or LED 0. Okay, we're going to take pin 2 And I'll try to keep this somewhat straight here for you. Pin 2 and wire it to the anode of the next LED. Then we'll go from pin 4, 1, 2, 3, 4, that's output 3, to the next anode. And then we'll go from pin 7, to the next anode. Okay. Then we'll go from pin 1 no, I'm sorry, pin 10. Okay, we're on the 5th one, so pin 10. So this will be pin 8, 9, 10. And that'll go to my next anode. And then we'll go from pin 1 to my next anode. Okay, then we'll go from pin 5 pin 5, 1, 2, 3, 4, 5, to my next anode. Then we'll go pin 6, looks like we got 2 more to go, pin 9, and finally pin 11. Pin 11, pin 9, so let's see, that's 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. If I've done everything right, I think it should work. I think I've checked everything. Okay, let's give it a go here. Okay, let me turn off the lights too, maybe. I don't know if that helps things or not. Okay, there's the sequential LEDs. You see them here? Now theoretically, we should be able to manipulate this potentiometer and get kind of a different flash rate. I know I can do that on a real breadboard, but I'm not sure we'll see it with this simulation. I don't know if you can kind of see a little difference there. Seems like it kind of goes a little slower at the beginning and then it kind of comes back. But the circuit is working, isn't it? How did you guys do with yours, huh? Hopefully okay. Well, so again, what we want to do is we want to take a screenshot and upload that to your checkpoint. Okay, so let's take a screenshot. I'll do it. Okay, make sure it's got your name there and what we just did. And there's my screenshot, and I'll be able, or you'll be able to upload that to your checkpoint. Alrighty, we'll talk to you later, kids.